Hello, welcome to our tutorial on using LaTeX to prepare scientific and mathematical documents. First of all, let's go ahead and download the materials for this tutorial from our GitHub repo. If you're using the BCE Virtual Linux machine, you can do this by simply typing git clone and then the name of the repository here. And that will go ahead and download all of the materials. I'm going to simply cd into the directory that was created. And in that directory, you'll see demopaper.tech, and that's an example tech file that demonstrates a lot of the functionality of LaTeX. Okay, let's go ahead and open up the HTML file for this tutorial, and also open up that tech file so we can go ahead and see some of the functionality. So I'm going to just go ahead and open those using this file manager. So here's the HTML for the tutorial, and that's the material that we'll be following along with here. And I'll also open up this demo paper tech file, and that just got opened up in a simple editing window. Okay, so here we have our demopaper.tech file. One of the first things to notice is that this is a simple text file. So LaTeX is not a word processor. LaTeX is a markup language and a program for basically taking that markup language and converting it into outputs, in particular into PDFs. So what you do when you write a LaTeX document is you specify what kinds of objects you want to include in your document, and then LaTeX deals with formatting those objects in one of a variety of different kinds of styles. So let's look at a few of the features of this document, and then I'll leave it to you to look at some more of the details on your own. So first of all, we start out the document with this command document class, and that in this case says we're going to use the article class. So this is going to be a scientific kind of article, and this is an option to the article class that says to create the document in 12-point size font. After that, there's a bunch of information here that's called the preamble. We'll come back to that in a minute, but let's ignore it for the moment. So the body of your document really starts with /begin document a little bit further down in the document. And then in this particular case, we've listed some authors with the author command and the title of the document with the title command. And then we've used the /make title command to say, actually go ahead and insert the title and the author and date information. Following that, we have a section for our abstract that begins with /begin abstract and ends with /end abstract, and then you type your abstract in here. And then after that, we basically have a whole series of sections and subsections that make up your document, including inclusion of mathematical equations, including of figures and tables, citation of references, etc., etc. And all of that syntax is illustrated here in the document. And then finally, towards the end of the document, what you'll see, say after a discussion and an acknowledgement section, is you'll see that we've also specified that we want to include a bibliography or a references cited section. And we say what kind of style we want to use for that bibliography. In this case, we're using something called the plain nat style. And then we use the /bibliography command to point to a file that contains a structured list of all of the potential references that we might cite in the document. And that document in this case is called refs.bib. That's another document that we can see appearing over here in the tutorial materials. In this case, by convention in LaTeX, you don't actually include the .bib suffix of the file name. You just include the body, the main part of the file name. And then your document has to end with /end document. So those are the main components of a LaTeX file. We can also look briefly at what the refs.bib file looks like. So I'm just going to use the less command so we can peek in at this file. And what you'll see is that it contains structured entries, each one of which has the information for an individual reference. So here we can see that there's a source written by these people here. These are the authors. It's actually in the form of a manual, and that's that syntax here. You can also cite scientific articles with this @article type of entry. and as well as books and other forms of entries, other types of references that you might cite. And what you'll see is that basically this is each of these entries is of the form a keyword and then the actual value for that keyword. So basically key value pairs for title and author and journal and that sort of information. So that's basically what your refs.bib file would look like. And then if you wanted to cite a particular reference at a particular point in the document, the sort of syntax that you use, if I can find some in here, is you would use the /cite command. So for example, here we go. Here in the introduction, I say /cite p. So that means to do a citation with parentheses around it. This reference, and this is basically a key. This is basically a key referring to an entry in that refs.bib. So we could go back and look at refs.bib, and we should see that somewhere in here, indeed, there is an entry that is this Banerjee et al. 2003 with this specific keyword that refers to that entry. So as a final note of some of the kinds of syntax that you'll see in a LaTeX file, I want to say a little bit about add-on packages. So basically, you've specified what kind of document you want to prepare here, and there are a variety of different kinds of documents that you could prepare. Each of these classes has a file that's called, for example, article.cls, or if you have another class, it would be named something.cls, and you would need that .cls file in order to be able to use that class. In addition to different classes of documents, you can also make use of additional add-on functionality within your document by using what are called packages. So if you wanted to use, say, the natbib package which provides that plain nat bibliography style, in the preamble, so before the /begin document, which occurs down here, in the preamble you would invoke that package with /use package and then the name of the package. I've also made use of a number of other packages here in the preamble, the times package, this GraphicX package for including figures, etc., etc. Every time you see a use package, that's an add-on package that's providing some additional functionality. I guess I don't have it in this particular version of this demo paper.tech file, but you will in the one that you're looking at. If I wanted to make use of add-on functionality that provides line numbering, I would just include use package, and then the left indicates to put it on the left-hand side of each page, and I would say I want to use the line number, line NO package, and in this case, to invoke line numbering, I then use the command /line numbers, and that command comes from this line no package. In other cases, for some of these other packages, you would actually use some of the commands from those packages in the body of your document as opposed to in the preamble. And then as a final thing, you can actually define your own commands that will then get used in the document. So for example, every time you see this /new command here in the preamble, that's defining a new command that you could then use later on in the document. So I define a command called /Matern, and all that does is it simply inserts, it simply writes out the name of this French person, Matern, but with the correct accent over the E. So instead of me having to write out this accent notation every time, I just type /Matern whenever I want that to appear, and I type that in the document wherever I want it to appear. So if we wanted to, we could search down later in the document, and you would see that I've invoked this /Matern command. So that's a very brief introduction to, or a very brief introduction to this particular demonstration file. You can look through it on your own to see some of the additional syntax and functionality, and in particular you may want to look at the PDF version of this paper, which is demopaper.pdf, and you'll see how each of the different pieces of syntax in this tech file, what they turn into and what they look like in the compiled PDF document. Okay, so suppose we have a LaTeX file that we've created and we want to create a PDF out of it. So let's take our demo paper.tech and see how we would go ahead and create a PDF out of that file. So I'm now on section 3 here. So if we're doing this from the command line, we basically need to invoke a series of commands. And the reason we need to do that is because LaTeX actually processes the document in multiple passes, and it needs to do that because there's a lot of cross-referencing between citations in the bibliography. There's cross-referencing in terms of numbering of sections and numbering of equations, and all of this requires that we run a series of commands. So if we wanted to create demopaper.pdf, it's already created here in the repository, but I'm going to go ahead and create it fresh from demopaper.tech. First of all, we'll invoke PDF LaTeX with the name of the tech file, but notice that I don't include the .tech extension when I do this. So that will go ahead and do a bunch of processing. If you look through the sort of voluminous output, there will be some indications in here, or actually there would be some indications in here if I hadn't already created this document, that some of the cross-referencing and the numbering was not yet done. Since I had already created the document, that's not the case here. And now the next thing I would do is type bibtech and then the name of the tech file. And that's going to go ahead and that will create a file called demopaper.bbl. So demopaper.bbl gets created by combining the information from the LaTeX file with the references in that refs.bib file, and then basically creating a formatted piece of LaTeX output that has the actual formatted bibliography. And so if we looked in demopaper.bbl, what we would see is a bunch. This is actually LaTeX syntax saying beginning of the bibliography, and then each of the entries uses this /bib item command. So actually, if you were to share a document, a LaTeX document with somebody else, for example, when you submit a journal article, oftentimes they'll actually ask you for the tech file and this .bbl file that gets created by bibtech. Okay, so we've now run PDF LaTeX once and we've run bibtech, and then the next step to make sure all the numbering and cross-referencing gets done is to actually run PDF LaTeX twice in a row. And so once you run it twice in a row, you should then have a document that has all the numbering and the bibliography all set up correctly. So we could actually go in and take a look at that document. So here it is demopaper.pdf, and what we should see here is that there are various places where I reference various references, and that those are actually included. There's numbering of equations. There's numbering of sections and references to particular section numbers and to figure numbers, and all of that gets done in that series of processing. And you'll notice at the end of the document that it's included this references section with an alphabetized list of all of the references that were used in the document. I'll also note that you can include items in that refs.bib file that are not used in the document, and those will not be included in this references section. The other thing to point out is that you don't need to name the file refs.bib, you just need to make sure that in the tech file that when you use the /bibliography command, you use the name of the actual .bib, one or more .bib files that you are trying to draw references from. Okay, the final thing that I'll demonstrate in this tutorial is the use of LIX. So LIX is a rather popular graphical front end to LaTeX. And what it does is it provides you with an editing window that has a bit more of the look and feel of a word processor, but all of the power of LaTeX for doing your formatting. And you can go back and forth very easily between a LIX document and a LaTeX document, and you can also include LaTeX code directly in a LIX document. So I have a LIX example that is a version of the demo paper file for LIX. And if we want to start LIX and tell it to open up that demopaper.lix file, we type LIX and then the name of the file, but again without the extension. So that's going to open up the LIX version of this file. And a couple key things to notice here is that whenever I want to include some particular kind of object, I do it using these various types here in this pull-down menu. So for example, all of these authors are indicated with the author tag. If I want to include a title, I use the title tag. And then once I get down into the actual just text of a document, you'll see it's just listed as standard here. If I want to include math syntax, I can basically just type Control-M, and that opens up a little math editing window. And at this point, I can just basically start typing directly in LaTeX math formatting. So I could, for example, say f of x. I hit and then equals, and now, oops, when I hit a space, it actually exited the math, this little math window here. So you can't just type a space there. So equals, and now if I wanted to create an integral, I can type /integral, and as soon as I hit a space, in this case, LIX will basically interpret that LaTeX syntax and basically convert it into a view of what it would look like. If I hit an underscore, I can then type in the lower limit of integration, and then a space. If I hit the caret, I can type in the upper limit, and then I could do things like this. I can type /theta and then hit a space, and it'll insert a theta actually formatted, and then I could continue on. So that's how I go about inserting equations and just typing in standard LaTeX syntax for the equation. I can also just type in anything in LaTeX, and then I could highlight it and type the TeX and press this TeX button up here, and that will basically tell LIX to interpret that as actual LaTeX code. Obviously, this is just simple text, so I wouldn't do that in this case. But I could insert any sort of LaTeX formatting that I wanted to by using this TeX button. I guess the main other thing to mention here is that if I want to export this as either an actual LaTeX file or directly as a PDF, I can go to File and then Export, and I generally choose PDF and then using PDF LaTeX, so that's how I would generally create a PDF. Or if I wanted to output this LIX file as a LaTeX file, I would generally choose LaTeX with the PDF LaTeX option here. And so that would allow me to create a demopaper.tex from the demopaper.lix file. I'm not going to do that here because I already have a demopaper.tex that was actually created simply by writing the text file. So I think those are the main things that I wanted to mention in terms of LIX. If you're interested in other resources in terms of LaTeX, there are a number of pointers here to material that you can go ahead and take a look at. And just simply Googling for LaTeX and then some particular functionality or syntax that you're interested in will often get you a lot of useful information.